Okay, this question says what temperature must be reached to increase a 100 milliliter sample of a gas initially at 300 Kelvin to a volume of 200 milliliters. So this question, again, the gas is changing, so I have to pick which formula I'm going to use. Since the gas is changing, the formula is going to be combined gas law, P1, B1, T2 equals P2, B2, T1. Now, when you read this question, pressure is not given, which means pressure is assumed to be held constant. So we're actually going to remove the variable pressure from our formula because we are assuming that pressure is constant, which means it's not changing and we don't need to account for it in our calculations. So it says what temperature must be reached to increase a 100 milliliter sample of gas initially, or the word initially means first, at 300 Kelvin. So what I'm looking for here is T2. So I want to get the variable T2 by itself. So to do that, I do algebra, take V1, divide it to the other side, and that's going to eliminate V1 from that side to give me T2 by itself. So that's step one, rearrange my formula. Step two is to check for any conversions. I see that I should convert my volume units because they're given in milliliters. I can make those liters. So real quick, 100 milliliters is 0.1 liters. That looks awful, but y'all know. 200 milliliters is 0.2 liters. Okay. And it looks like I'm already ready to plug in my equation. So V2, my second volume was 0.2 liters. T1, or my first temperature, initially was 300 Kelvin. And then volume 1 is 0.1 liters. Okay. So in doing my calculations, I get an answer of 600. And since I'm calculating for pressure or for temperature, sorry, that unit is 600 Kelvin as my final answer. Now, those of you who are really getting a good handle on this chemistry stuff, there is another way of thinking about this problem. If pressure is constant, we know that this is a Charles law problem. And remember, when temperature increases, it's a direct relationship to its volume. So what you can remember is that if I'm increasing the volume by 100 to 200, then my temperature is going to increase by 2. So all you could do is do 300 Kelvin times 2, and that'll be 600 Kelvin.